Okay, imagine a world, and it's not far off, where your car just drives itself.
Yeah.
Or doctors spot diseases with, like, incredible accuracy. Even art being created by machines.
Right. It sounds like sci-fi, but it's really happening now.
Exactly, and it's largely thanks to these two, well, intertwined fields, machine learning and deep learning. So today we're going to dive deep, really unpack these AI powerhouses.
Pull back the curtain a bit.
Yeah, see how they're redefining what's possible.
Hmm.
Our mission, really, is to cut through the jargon, pull out the key insights from our sources, and give you a really clear picture. What are the core ideas, how are they different, and the, frankly, mind-boggling impact they have on your life.
So you walk away understanding what's actually going on under the hood.
Precisely. Not just informed, but, like, genuinely insightful about these huge shifts in technology.
And what's really interesting, I think, is how they build on each other. AI, artificial intelligence, that's the big umbrella.
Right, the whole field.
Exactly. Then machine learning, ML, fits inside that as a major part. And deep learning, that's an even more specialized, really powerful subset inside machine learning.
Okay, so it's like layers of an onion, sort of increasing complexity.
That's a good way to put it. A progression of complexity and capability.
Okay, so let's start with machine learning then, the foundation you said. What's the core idea there? I mean, computers have followed instructions for ages. What makes ML different?
Yeah, that's the key question. The big difference is that ML teaches computers to learn from data, to actually improve with experience, rather than needing explicit programming for every single task.
So less hand-holding.
Much less.
Yeah.
Instead of giving a computer a step-by-step rules to, say, spot a cat in a photo, you feed it thousands, maybe millions of pictures, some cats, some dogs, and it figures out the patterns itself. It learns the distinguishing features.
Oh.
And the real power isn't just that it can learn, but that it can often find patterns that we humans might miss entirely. Connections in massive, complex data sets that are just too much for our brains to process effectively.
Finding those invisible threads, like you said, that's a huge shift.
Yeah.
So if it's learning by itself, how does that actually work? What's the mechanism?
Well, it all boils down to data. Lots and lots of data. ML models are trained using these vast data sets.
Right.
The algorithms sift through this data, looking for those hidden patterns, those relationships. But first, and this is crucial, the data needs to be collected and cleaned up. Quality is paramount.
Garbage in, garbage out, right?
Exactly that. So you get this high-quality data, and you feed it to the model. Sometimes it gets inputs and the known correct outputs. Other times maybe just the inputs. And the machine works to identify the correlations.
And it keeps learning.
That's the critical part. ML applications get better over time. The more data they process, the more accurate they become. It's this continuous feedback loop, constantly refining itself.
So it's dynamic, not static.
Okay.
Now, you mentioned learning, but it's not just one way of learning, is it? I gather there are different flavors of ML.
Absolutely. Depending on the problem, you'd use a different approach. There are three main types, really.
Okay.
First up is supervised learning. You probably encountered this, even if you didn't know the term. This is where the algorithm learns from labeled examples.
Labeled.
Meaning the data comes with the answers, like showing a kid pictures labeled cat or dog. The model gets input data and the correct output data. Its job is to figure out the mapping, the relationship, so it can predict the output for new, unseen inputs later.
Ah, like spam filters or predicting house prices?
Exactly. Classic examples, image classification, prediction tasks, that's often supervised learning.
Got it. What's next?
Next is unsupervised learning. This one's a bit more exploratory. Here, the model gets unlabeled data. No answers provided beforehand.
So it's just...
Pretty much. It has to find hidden patterns or structures within the data all by itself. Think about customer segmentation, grouping customers based on purchasing habits without knowing the groups in advance, or finding anomalies like unusual transactions that might signal fraud. The machine finds the structure.
Okay, discovering patterns we didn't even know were there. Interesting. And the third type?
The third is reinforcement learning. This one often feels the most, active or intelligent. The model learns by interacting with an environment.
Like trial and error.
Exactly. It takes actions, and based on those actions, it gets rewards or penalties. Over time, it learns which actions lead to the best rewards, optimizing its strategy to reach a specific goal.
Like training a dog with treats.
Precisely. Or think about AI learning to play complex games like Go or chess, or even optimizing traffic lights in a city based on real-time flow. That's reinforcement learning.
Wow, okay. 3 very different ways to learn. Guided, self-discovery, and goal-driven. So that's the ML foundation. Now, deep learning, You said it's a subset, but more advanced. What's the core idea that makes DL different?
Right, deep learning, or DL. It is a type of ML, but its defining feature is its architecture. It relies on artificial neural networks, often called deep neural
Neural
networks.
networks inspired by the brain, right?
Loosely inspired, yes. And the deep part isn't just a cool name, it refers to the structure. These networks have many layers, sometimes dozens, even hundreds, of interconnected processing units stacked between the input and output.
Multiple layers.
Yes, multiple hidden layers. This layered structure allows the machine to learn features and representations of the data at different levels of abstraction. It starts simple and builds up to more complex understanding. That's what lets DL tackle really complex problems, especially with unstructured data like images or sound, often without needing much human guidance on what features to look for.
Okay, so those hidden layers are the key. Can you expand on that? How do they actually work? What happens inside?
Sure. Think of data flowing through the network. The first layer, the input layer, gets the raw data like the pixels in an image.
Hmm.
Then, this data passes through the hidden layers. Each layer transforms the information it receives from the previous one. Early layers might detect simple things, like edges or corners in an image.
Okay.
Subsequent layers combine these simple features to recognize more complex patterns, maybe shapes or textures. And layers deeper still might combine those shapes to identify objects, like a face or a car.
So each layer builds on the last, getting more abstract.
Exactly. More layers generally mean the potential for more complex, nuanced understanding. The network learns which features are important at each level during the training process, adapting its internal connections. This multi-level analysis allows DL to tackle problems like distinguishing subtle differences between similar objects, which is much harder for traditional ML.
Right, the architecture itself enables that deeper understanding. This brings up a really important point. People often use ML and DL almost interchangeably. You hear them thrown around. But our sources stress there are key differences. Where does the confusion come from? And what's the crucial distinction we should remember?
Yeah, that's a super common point of confusion, and it's vital to clarify because the differences really impact how and when you use them. The confusion often stems from DL being, well, a type of ML, but it's a very specific, advanced type.
So what are the main takeaways on the differences?
Okay, let's break it down. Key differences. First, structure. ML uses a whole toolbox of different algorithms, some quite straightforward. DL specifically uses those complex, multi-layered neural networks. That's its defining feature.
Okay, networks versus broader algorithms.
Second, data volume. This is huge. ML can often work pretty well with smaller data sets. Deep learning, though, it's a data hog. It needs massive amounts of data to train effectively because it has so many parameters to adjust in all those layers.
Needs way more data.
Got it. Third, feature engineering. With traditional ML, humans often need to do a lot of upfront work selecting and crafting the features, telling the algorithm what parts of the data are important. Deep learning largely automates this. It tends to learn the important features directly from the raw data itself.
So DL is more self-sufficient in finding what matters.
In that sense, yes. Much more automatic feature extraction. Fourth, processing. ML is great with structured or semi-structured data, think spreadsheets or databases. DL shines when dealing with complex, unstructured data like raw images, audio files, natural language text. It can handle that messiness better.
Right, images, text.
And finally, accuracy. For simpler tasks, standard ML can be very accurate and efficient. But for really complex pattern recognition, especially with those huge unstructured data sets, deep learning often achieves significantly higher accuracy.
So better performance on the really hard stuff.
Generally, yes. But these differences are crucial. Choosing DL when simple ML would do might be overkill. It demands more data, more computing power. It's about picking the right tool for the job based on the data you have, the complexity, and your resources.
That really clarifies the trade-offs. It's not just use the fanciest tool, it's about suitability.
Yeah.
Okay, this sounds incredibly powerful, but let's ground it. How are ML and DL actually showing up in our daily lives and industries? Where do they really shine?
Oh, they're everywhere, often hidden in plain sight. For machine learning, think about the recommendation engines you see constantly. Netflix suggesting shows, Amazon suggesting products. That's ML analyzing your past behavior and comparing it to similar users.
Right, personalization.
Exactly. And in healthcare, ML is becoming huge. Analyzing medical images like X-rays, predicting disease risk based on patient data and genetics, helping doctors diagnose conditions like cancer or diabetes earlier. It's pattern spotting on a massive scale.
Okay, so ML is widespread in those areas. What about the specific strengths of deep learning?
Deep learning really excels with that complex, raw data. Self-driving cars are probably the most talked about example. DL models are what allow the car to see and interpret its surroundings in real time, detecting cars, pedestrians, signs, lane markings. It's processing a constant stream of visual data.
Object recognition in motion.
Precisely. Another huge area is natural language processing, or NLP. The reason your phone's voice assistant understands you, or why online translation tools have gotten so much better, that's largely thanks to deep learning models understanding the nuances of human language.
So Siri, Alexa, that's DL.
Often, yes, DL plays a big role in the underlying technology. And in medicine, beyond general ML, DL is used for really fine-grained image analysis, spotting tiny cancerous nodules in scans that might be missed, or analyzing microscopic details on pathology slides. Incredible precision.
It's truly amazing how embedded these are. You almost take it for granted sometimes. But like any powerful tech, it's not all smooth sailing. There are upsides, but also challenges, right? What are the main pros and cons we should be aware of, especially with deep learning?
Absolutely, it's crucial to see both sides. The advantages of deep learning are pretty compelling. First, as we've said, its ability to handle complex, unstructured data images, text, audio directly. That's a massive advantage over methods that need structured input.
Dealing with messy, real-world data.
Second, the potential for performance improvement. Generally, the more good data you feed a DL model, the better it gets. It learns, adapts, refines. This scalability is key.
It gets smarter with more experience.
And third, the sheer breadth of applications. We've touched on medicine, transport, e-commerce, but it's impacting manufacturing, finance, entertainment, delivering intelligent solutions across the board.
Okay, those are big pluses. What about the downsides, the challenges?
There are definitely significant challenges and limitations. The biggest is probably its hunger for data. Deep learning models need enormous data sets to train effectively and achieve those high levels of accuracy. Getting enough high-quality, labeled data can be a major hurdle.
The data bottleneck.
Second, they're often incredibly resource-intensive. Training large deep learning models requires serious computational power, expensive GPUs, lots of memory, significant time and energy. That's not always feasible for everyone.
So costly to train.
And third, while powerful, they learn from examples. Just like us, they need exposure to a wide variety of scenarios to generalize well. If the training data isn't diverse enough or has biases, the model's performance will reflect that, potentially leading to errors or unfair outcomes.
Right. Bias in the data can lead to biased results. Makes sense. The power comes with requirements for data and resources. This actually leads us nicely into something that's really exploded recently and builds heavily on DL, generative AI. It's everywhere now. How does this generative aspect fit in? What makes it different?
Yeah, generative AI is definitely the hot topic, and it marks a really interesting shift. Generative deep learning is a specific branch within DL that focuses not just on analyzing or classifying data, but on creating new data.
Creating, like making new things.
Exactly. So traditional DL might learn to recognize a cat. Generative DL learns the underlying patterns of what makes something cat-like and can then generate a brand new, unique image of a cat that never existed before. It adds generation to pattern recognition.
Wow.
These models find patterns and then use them to synthesize novel outputs, images, text, music, code, you name it, that mimic the characteristics of the data they were trained on.
And generative AI is the bigger picture.
Right. Generative AI is the broader field that uses techniques like generative deep learning and others to produce this new content. Think of tools like ChatGPT, MidJourney, Stable Diffusion. They generate text, images based on prompts.
The text-to-image craze, AI writing assistant.
That's all generative AI. And these models often leverage absolutely massive amounts of pre-trained knowledge. They've essentially digested huge swaths of the internet, books, images, which allows them to generate such diverse and often surprisingly coherent new content. It's a major leap, opening up totally new avenues for creativity, automation, and, well, disruption too.
A really profound shift from analysis to creation. Okay, wrapping this up. Thinking about all this, machine learning, deep learning, generative AI, what does this really mean for you listening? As these technologies weave themselves deeper into our lives, how do you see them shaping your world? What possibilities or maybe even concerns pop into your mind?
Well, to bring it all together, what we're seeing with ML and DL is the creation of computer systems that can tackle tasks once thought to require human intelligence. Recognizing faces, understanding spoken language, translating between languages, even driving cars.
Doing human-like tasks.
Essentially, yes.
Yeah.
And these technologies aren't just some far-off future concept. They're actively shaping our present, evolving constantly, finding new uses almost daily. And we fully expect this growth to accelerate. More data, more powerful computers. It just keeps opening up new possibilities, new frontiers for innovation in this whole AI era.
It's a truly transformative time, so we'd genuinely love to hear your perspective. What are your thoughts, your predictions on where this is all headed? What stood out from our discussion today, and what questions do these powerful tools raise for you?
Please do share your insights, your suggestions. Let us know in the comments section or wherever you're tuning in.
Absolutely. And if you found this deep dive insightful, if it helped clarify things for you, please do consider showing your support. Like this episode, subscribe to our feed, maybe hit that notification bell so you don't miss future explorations.
And sharing it with others definitely helps too.
It really does. Your support lets us keep bringing you these kinds of in-depth looks at the technologies and ideas shaping our world. Thanks for joining us.